We'd like to welcome Chris Elliott, Solutions Architect, to talk about Google Cloud.
Thanks. Glad to be here. So fun story, when you get really close to time, there's an entire Google posse that stands up in the corner and starts going like this and walking closer. So that's a great counter. So we're going to talk about Google Cloud Platform and how you can build games that are scalable and will really be able to handle the load when you launch. So my name is Chris Elliott. I always like to start with a terrible picture, and this one is actually one of my favorites because it's in publications that are commonly found in restrooms all over the world. So on my resume literally is a bullet that says found on toilets all over the world, and it's a terrible photo, but as an architect, I work and help tie together the platform to solve a lot of the real-world use cases that people are tackling, game developers specifically. So about that, basically 4 sections here broken down into. First, just an overview of the platform. Make sure we're all on the exact same page in terms of the core fundamental building blocks there. And then really the meat and potatoes of diving into some example real-world implementation that developers have built, and also talk about a few ideal in a kind of ideal world of what you could build, so you can kind of mix and match and choose what works best for your use case here. So when looking at the Google Cloud Platform, we provide a variety of compute platforms, storage services, and additional services to layer on top of that. And really, it's a little bit confusing because there's a lot of moving parts and you're not quite sure which one is the best one to use for a use case. And so I hope by the end of this session, everyone here will understand some potential ways of combining these technologies to solve the really challenging problems we face. And rest assured, you're not alone. We have a lot of customers who are very happy in the game industry building on our platform. And it's amazing because usually you see a couple developers kind of build something on it that scales and goes and doesn't crash. Everyone kind of picks up on that, and you see Google Cloud Platform adoption just growing within companies. And here's a couple of examples, and you'll notice it goes everywhere from small indie studios all the way up to AAA game studios. We see everyone across the board benefiting from the value and power of the platform. And a couple of examples, for example, Electronic Arts initially started with just one mobile title, but it scaled, it didn't go down, it didn't crash, it was a small dev team, it was ideal, and it made everyone else envious who was hammering away and managing their own infrastructure. And then now they're using it for a lot of their mobile applications that they're building out, and you may recognize a few from here. Another one, and actually, I found this out last GDC when just talking to Epic Games, that they actually used App Engine for Infinity Blade 2, and the compelling social features there. It was really cool, too, because it was done by just one guy in about 6 weeks. And that is a really compelling note, because if I was a developer and I had 6 weeks to build something I knew millions of people were going to be hammering, I would be on the edge of my seat. And luckily, it scaled up and it handled, and it just worked. And it's just another one of those example use cases where people are really harnessing the power of the platform and using the right tool for the right job. And so, to look at a few building blocks, really when building on the Google Cloud Platform, the 2 things you have to choose about are whether you want to use Compute Engine, App Engine, how do I mix and match, and really what is the best tool for my use case. So we'll start with Compute Engine, which there's been a lot of excitement around recently since we went GA in December. And with that, the core way to describe the platform is its virtual machines. Open and flexible virtual machines that you can bring whatever software stack you want and run that on a Linux machine and be good to go. And so bring your dedicated game servers, anything that you want that doesn't quite necessarily fit within the App Engine containerized environment, it's a great fit on Compute Engine. And the next couple of slides, there are really 2 points that I've seen be very compelling for game developers. The first one is the global network and the performance of the network opens up new opportunities with respect to cloud gaming. And also, the consistent performance. Not only is it a very high performance system, every machine performs at a high level, so you can design around, you can design depending on those consistent benchmarks in the back end. And so with that, the first network really is the first point is really the network that spans the globe. We have our own private fiber network, and Compute Engine taps into that. It's built on Google data centers, and it really allows you to do things that you can't and have never been able to do before on previous cloud platforms just because you're running over Google's private fiber. One of the fun parts about being inside Google is you get to see kind of behind the scenes. There's a really classic video of inspecting one of our transatlantic fiber lines, and out of nowhere, a shark comes out, bites onto the cable, and luckily the cable is wrapped in Kevlar and designed to withstand shark attacks, and it's really cool to actually be able to go and see shark attacks happening and knowing that your app's still going to go. And although the fiber can withstand that, if I was a developer and I had a small little outage for 1% and it was due to a shark attack, I would actually be much more comfortable than, say, a go-to fail statement issue. I would much rather have a shark attack happening. But anyways, we get a lot of press on platform, and people are really picking up on what we're doing. This one quote in Wired I absolutely love because it summarizes everything we're doing and how we're exposing Google's history and experience with infrastructure to external developers to get in and harness that power. And it really sums up as the mother of all clouds. And yes, our data centers really do look like that. There's some really great pictures there, and one of them you might have seen the Easter egg with a stormtrooper in it, and I'm pretty sure that exists there as well. But people are noticing this. I worked with Ed over at PA Consulting on a bunch of Chrome Jam projects. One of them was, one was called Chrome Jam, and these are projects by the Chrome team. And this one was basically required very low latency connection so they could stream audio between 4 clients and friends could just jam on, log in, choose an instrument, and just start jamming with each other. And this quote was straight from them. They absolutely loved the latency that they were seeing. It was low, much lower than they were designing for elsewhere, and actually allowed them to launch successfully instead of having to scrap the project because of latency. What does that actually mean in numbers? Well, here's a study that, although it's over a year old, these numbers just get even better and better from this point on. And all the coloring is accidental of other, but it's fairly accurate per se. But this is between 2 regions and what you can see. And the really key thing is trying to highlight, as game developers, what are the key metrics? Latency. We're looking at significantly lower latency that enables you to do things that you haven't been able to do before across regional deployments. And also bandwidth. Every instance within Compute Engine exists on a project private network and can communicate over an internal network. So you can literally create an instance in EU, create an instance in US, and say, ping my European instance, and that's all over internal private network. Of course, you have to have firewall ports open and all that, and we walk you through that, but it's one of the powerful features. And even instance creation, although it doesn't necessarily involve having a faster performing instance, the fact that you can create an instance and go to SSH into it and it's almost always there, that is very compelling. I'm no longer just sitting around waiting for my instances to be created, and it's great when you're spinning up 1,000 instances to meet with unexpected surge in demand. And one last benchmark, just to kind of give you a sense and validate what we're talking about here in terms of performance, is this MapR Terasort record. And there are 2 reasons I really love this for gaming. One is the previous record was held on dedicated hardware in their own data center. And we smashed that record for sorting a terabyte of data on a cloud-based deployment. Nobody would have expected cloud performance to exceed that of what they had on dedicated hardware. And you'll see that we used 1/3 of the number of cores. And the other aspect is, and the reason this was possible, is because of that consistent performance. You don't have a couple of MapReduce nodes hanging around, being slow, dragging the entire job back down. Everything spins up quickly, computes, shuts down, and that's why they're able to smash that record. And for gaming, it's important. If you have 2, 3, 5% of your servers not performing correctly, you're going to have 5% of your user base having a bad experience, and this is one of the ways we can help avoid that problem. So the other aspect, and I'm not spending a lot of time on it in this overview because a lot of people I talk to are already intimately familiar with App Engine and understand what it provides. They may love it, or they may have not used it for other reasons, such as wanting to run their own dedicated game server that doesn't work within the App Engine container. But I absolutely love App Engine. It scales to unbelievably heights. The developers I've worked with that have built on it have been doing amazing things with extremely small teams. Easy to build, easy to scale, and if you're running in PHP, Go, Java, or Python, it's always great to evaluate if it's a right tool for your job or whether you need to leverage and add on other things such as Compute Engine. So that's really the high-level overview. Just trying to keep it brief, and I'll be around afterwards if you have more questions about those components. But really want to jump into some things that people are actually building and what did it look like. So the first one is Song Pop. How many people in the audience have played this game, out of curiosity? A few hands. So about 80 million users played this game, fairly successful by app standards. And basically, it's you go in and you compete against your friend for who is the best at song trivia. Do you recognize this song? Do you recognize this title? Do you recognize this artist? And so with that, this is their daily active users. And I remember being involved at about near the very beginning of that hockey stick and hearing about this app and how it was growing massively. And then it just kept going and going, up into about 300 million requests per day, and this is all backed by App Engine, and 3 billion data store operations per day. And the most amazing thing about this is there was one backend developer for this game, and he actually got to enjoy his weekends off and sleep at night. And they actually attribute App Engine to be one of the reasons why they're successful, because instead of worrying about their system scaling, having to maintain a NoSQL database that is doing 3 billion rows, 3 billion operations per day, instead they're able to focus on adding the features people are asking in order to keep that hockey stick growing. And they absolutely love the platform and have released their newest title on as well, called Movie Pop, which you can probably guess the spin on that, but it's also really cool. And so what does the architecture look like behind this? Well, here's what it looks like. It's actually pretty straightforward, it's efficient, and it gets the job done and scales. And you'll notice I say scale a lot during this talk, but scaling really is the heart of everything we try and do at Google and expose to all developers out there. And so the key aspect of this is the core game logic running on App Engine instances. They're using Python, and having all those mobile devices syncing into App Engine, have all the game logic there. For example, all the user profiles are stored in data store, all the songs, all their scores, all the playlists they played, all their friends stored in the data store. And so when you have 80 million users, you need a NoSQL database that scales up and can handle that load. And similarly, all of their songs are stored in cloud storage. So what happens is you'll request to play a game with a friend, they'll get a push notification, and then you'll both retrieve that data from cloud storage of all the song samples, play, and then push the results back into App Engine. And so it's fairly straightforward, but it scales when you use the components right, and they're designed for scalability in mind. And I'll talk a little bit more about the extra components here in other architectures as well. And another one that I was lucky enough to be involved with at the very beginning is Motorola Spotlight Stories. Out of curiosity, how many people have Moto X in the audience? And how many of you have played the Spotlight Stories? And they're awesome, right? Yeah, they're absolutely awesome. A friend of mine reached out at Motorola and asked if I'd be interested in helping out some 20% project work. So I went over, talked to the team at Motorola, and I was blown away because behind the store was this creative team that worked on so many of my favorite Pixar movies. You had Oscar-winning directors, you had the animator who animated Woody in Toy Story. Everyone was there in the room, and I had no idea what to expect when I was just asked to come and help out with 20%. Ironically, I had glass on, and it was still fairly new, and so I was both in shock, and they were both in shock, and we kind of had a moment. But they got an amazing creative team, spent a ton of time building their own custom game engine, and hiring amazing animators. Everything here is hand-animated, frame by frame, and if you have a Moto X, or you know a friend with a Moto X, just ask to borrow it. I'll always remember in the office, we have a lot of Moto X's at Google, and everyone there is just looking around and interacting in the world, and it's just an amazing experience and really cool stuff they did. But what does it actually look like? Well, here's the core architecture. So on the Moto X itself, they wrote their own native engine, OpenGL 3.0, some really great stuff there to power the in-game, and it runs on Android 4.4 KitKat. What's interesting there is the actual Java services they've implemented. And so all of the story, scripts, and art assets are kept within cloud storage. So what happens is your device, about once a day, just checks in with App Engine, check and see if there's any new content, stories, anything at all. And if there is, it gets that information from the data store, and then App Engine will return a signed URL to the device, then it can then download all of those assets to the phone. And similarly on the cloud, you have the admin panel for adding new assets, adding new stories, and that's kind of the cloud platform aspect. And the other interesting thing they're doing here is their engine service. I mean, this is perfectly timed after the analytics session, and so they're using Google Analytics for everything to see how users are playing, how many times are people playing it, if you actually play one of the movies like Windy Day or Buggy Night, you can follow along the story and kind of interact with it, but if you just detour off, there's all these really funny things you wouldn't even notice are happening unless you kind of take your time. And you can get a sense for what people are looking at, what really excites people, what do they look at a lot. So that's kind of the architecture behind that. And more than willing to talk about these later on, and there's lots of architectures, but we have 30 minutes, so this is a whirlwind tour of everything great in cloud. So now we're going to talk about some reference architectures here. And these really are, in an ideal world, what would the perfect implementation look like on Google Cloud Platform. And feel free to mix and match and choose whatever is best for your implementation, because there's no wrong way to build. You use the tools you're familiar with and sprinkle in the technology that you know is going to be there for you when your game grows. So the first one we're looking at is gaming reference architecture, specifically with player versus player, intense multiplaying, low latency dedicated game servers. So the past two we talked about were more mobile-focused, mobile device-focused. This is what I do when I get home for 5 hours until I can't stay awake anymore. And it's really about building a full-featured gameplay experience. So with these reference architectures, we like to pack up a sample application as well to show you that it's fairly straightforward to get the bare-bones implementation up and running so you can start sprinkling in custom logic. And for that, about 2 years ago at Google I/O, Colt actually, developed this game called Grits, and it was meant to show HTML5 and having a whole bunch of robots running around on screen shooting each other. We took that as the core gameplay element and sprinkled in the auto-scaling game cluster aspect. So essentially what you have is this core fun gameplay mechanic requiring dedicated servers, and what we've added to it is a whole bunch of App Engine logic for scaling up, scaling down, maintaining status of all the clusters, and doing some of the straightforward matchmaking logic. So what does this actually look like? Well, I apologize for the big architecture diagrams to start. Typically, I like to reveal these, but then I feel bad because everyone in the audience takes a picture, and the next slide, oh, there's more, takes a picture, and about 8 slides later, it's finally revealed. And so with this one, and the thing I really want you to focus on is down in the bottom, you'll see compute engine instances connected to the mobile devices. And that is where the majority of the gameplay of the player is going to happen. It's just directly connecting to those instances, running the dedicated game servers, handling all of those connections. But as you know, there's a lot more that it takes to actually make a game that players are going to come back to and that they're going to have a great time with. And that's really where App Engine comes in as the brains of building a game type like this, a game like this. And Compute Engine is really the brawn of just running the dedicated game servers. So with respect to server matchmaking, Memcache is low latency in-memory caching, and you want to think about, for example, keeping a list of all your servers and their current stats in Memcache, so every single person who looks for a server can instantly get that back, and you're not taking the cost of extra data center reads with respect to latency and monetary value as well. Another important thing as well is processing in-game requests. If players have custom configuration, they want to download that down to the game server, or if they want to purchase things, or if you want to keep track of kill-death ratios at the end of a match. All of that can be sent into App Engine and stored within Data Store and all the player profiles that can be built up there by relying on the Data Store and that scalable technology. And you'll notice that everything's going through this cloud endpoints, and this is a fantastic technology that provides RESTful APIs, strongly typed libraries, and authentication. I had to do all of this before Cloud Endpoints was available, and you kids these days just have it so lucky. And Cloud Endpoints abstracts away a lot of the complexities there. But if you want to use your own authentication RESTful API system, you're feel free to sprinkle that in there as well. And the last aspect is the virtual machine orchestration, and that really is scaling the cluster up and down with respect to demand and player load. And there's actually two things that make that great on Compute Engine. One is we do minute billing. So if you need to spin up and burst and then terminate down instances, you don't have to worry about, oh, I'm getting billed by the hour, how's my logic take into account that? You can just terminate an instance and you're only charged for what you use there. Similarly, the consistent performance that you know you're not going to have to keep an eye on your instances and find the ones that are underperforming, so you can go in and terminate those out. And so the final last aspect of this architecture, I swear, is the big data aspect of it. I know that's a really fuzzy term. There's a lot of different ways of looking at that and slicing and dicing it. And just one example here is you have all of the game server logs, every single player action, everything people are doing. Dumping that into a permanent storage and cloud storage is easy, and it's really cheap to keep it there long term. And then you can start to do things like MapReduce jobs over that to aggregate down to player actions per day instead of every single player action. And from there, you can pipe into tools like BigQuery that can do ad hoc real-time analysis on billions of rows of data. And so there are these tools that allow you to get really great insights. And typically what we find is people start building on the left, get the core gameplay working, and as they scale and as they grow, they start to sprinkle in more features, and eventually they're into BigQuery to actually understand and get insight into what's happening with their applications. And so one more reference architecture for you here. And this is along the mobile gaming one as well. And this is your typical mobile gaming application with a complex backend. where you're supporting multiple devices, you're scalable to millions of players, and you really want to sprinkle in the engaging social aspects. And with that, we have an awesome sample application, which if you want to just throw something out there in the App Store, you can download this, put it in the App Store or the Play Store, and see if you can get any revenue driving from it. It's actually full-featured and pretty awesome to add more riddles to it, etc. And so what this game is, it's called Griddler, and essentially it's kind of a player versus player asynchronous game, where you get a riddle such as what has to be broken before it can be used, and you highlight, oh, egg. And so you highlight egg, and so you're competing against your friend to go through all of these different riddles and get a score at the end. And so that asynchronous game works really well on App Engine. We see a lot of people being very successful with that architecture and game type. And now you have a great starting point available on both Android and iOS to move quickly there and have a base implementation to start building on. And what does that look like? Well, similar to what you saw for SongPop, except we've added a little bit more in here with respect to other components that can drive value. And so you have your iOS, Android devices, through cloud endpoints to App Engine. And one of the interesting things I'll actually point out here is the task queues and schedule tasks and App Engine backends. If you've used iOS push notifications, for example, you know they like you to maintain sockets and not just open and close a million sockets. So what you can do is have a few backends on App Engine running continuously, and what they do is they'll pull push requests from the task queue, batch those together, and then push those over Apple push notification, just so you can kind of tap into what Apple expects you to do with respect to push notifications and harness the scalable components within App Engine and the task queues, etc. And that's just one of the ways, and we actually have a sample for that as well if you're interested in doing that. And the other aspect here that's worth calling out is cloud storage, once again. And you don't have to choose between App Engine or Compute Engine. It's really about picking the best tool for what you're doing. And so say you have an application where people upload pictures and video and you want to do some transcoding or image manipulation on that, you can upload that through App Engine, dump that into cloud storage, and then using task queues, you can actually orchestrate the processing of those videos with Compute Engine, whatever custom software you want to run on that, and then put it back in cloud storage and send notifications back. There's lots of flexibility here and a million different ways to combine these components and really pick what works best for your use case and application. And so just to quickly wrap it up here, what we've seen is really sorry for the cropping at the very top. I'm not quite sure what happened there. But we've seen Google is the best place for developers. From AAA to indie studios, we love seeing what people are building on the platform. If you have anything great or you're thinking about it, please talk to us. We'd love to hear from you. You'll see there's a couple of Google employees in the audience, and they may be heads down on laptops. Apologies for that. It's performance review season at Google, and everyone's a little bit stressed out about that. But we're more than happy to talk to you and put our laptops away. And with that as well, we have papers talking about the reference architectures, and we also have those sample applications. If you just Google any words that come to your mind from this session, you'll probably find them. Otherwise, cloud.google.com, the papers are all there to go in and look at. Otherwise, our GitHub account has the samples on it. And this link here is to a prettier GitHub version that has a little bit more readable, but you'll also find everything on the cloud GitHub account. I guess I'll leave that up for one more minute, given the pictures here. But if you just search for whatever's in your mind, you'll find it. I've done it a million times. And so lastly, this one actually I really want to take a picture of, and this is a really cool deal, is $2,000 in cloud credits. Basically, wow, that QR code became giant on that screen. That's taller than I am. But go there, enter in the form, enter in a project ID, and you'll get $1,000 of App Engine credits, which will take you quite a long ways, and also $1,000 of Compute Engine, which you can go very far on, especially if you turn down your instance and take advantage of minute billing. I've seen people build some amazing systems and run a quick test. OK, tear down the instances, change things for now, and then run another quick test, tear down the instances. Great options there for maximizing your use case of these credits. And that's basically it. I realize there's no Q&A, but thank you, and I'll be around if you have any more questions.